Unit 5, Video 8, Solve by Quadratic Formula. Quadratic formula is used to solve any kind of quadratic equation. So it's a formula. X equals negative b plus or minus b squared minus 4ac, under the square root, all over 2a, where a cannot equal 0, and b squared minus 4ac has to be greater than or equal to 0, because you can't have a negative underneath a square root. So down here they tell you can read it. X equals the opposite of b plus or minus the square root of b squared minus 4ac, all divided by 2a. Okay, so here's just a good reference of here's what a quadratic equation looks like, and here's what it looks like in the quadratic formula, so you know where things are being pulled from. Different parts of the quadratic formula, again, you see here at the top, the standard form of the quadratic equation, and then now where you can identify what the A is, what the B is, and what the C is. And notice in this example, you have those minus signs. Those take into account what that B and that C value are. Simply just the quadratic formula, really, really big and bold for you to write down or have, because you need to memorize this one. I really like this image because it shows you where you're going to start inserting things. So you're going to insert your A. Here's your A value in your equation. Your A goes there and it goes there in the equation. Here's your B in the equation. Your B goes there and B goes there in the formula. C, your C only goes there in the formula. A couple things we need to note. This is just another way to solve a quadratic equation that will work every single time, even when it cannot be factored. Okay, we just learned factoring, but this one will work every single time. It's okay to get decimals for your answers, and please round to the nearest hundredth. You will always get two values for your x's because, again, we're talking about where this quadratic crosses the x-axis, and it must always be solved equal to 0 for this formula to work correctly. Okay, so we're going to try an example. M squared minus 5m minus 14. So the first thing I need to do is I need to identify my A, my B, and my C value. Okay, so now we need to identify our A, B, and C. So A is 1 because that's the coefficient of the m squared. B is a negative 5 because that's the coefficient there to the m. And C is negative 14 because that's the value there that has no variable. So now we're going to plug in the quadratic formula using our A, B, and C value. Okay, notice my use of parentheses, all right? So I put parentheses here because it's a negative B, so it's a negative of negative 5 since my B value is negative 5. Plus or minus, square root, got a b squared, so I have parentheses with my negative 5 squared minus 4 times a times c. My a is 1, my c is negative 14. All over 2a, so 2 times 1. So now I'm going to start simplifying. Okay, negative 5 is a positive 5. Keep the plus or minus, keep the square root for right now. Negative 5 squared would be a 25. Negative 4 times 1 times negative 14 would be a plus 56. And 2 times 1 would be a 2. So now we're going to keep simplifying. So I simply added my 25 plus 56, and I got an 81. But I know the square root of 81 is 9, so I can keep going. So now I have the problems, x equals 5 plus or minus 9 over 2. So I'm going to separate it into two problems at this point. So as I separated the problem into two problems, I have x equals 5 plus 9 over 2 and x equals 5 minus 9 over 2. So x equals 14 over 2 and x equals negative 4 over 2. And yes, I'm going to simplify it even farther because I can. And I end up with x equals 7 and x equals negative 2. And yes, this one could have been factored because I got these pretty numbers. But the rest of the examples will not be able to be as cleanly factored. So that's why we like to use quadratic formula. Okay, so the next problem is 2x squared minus 3x minus 20 equals 0. So we're going to put it into quadratic formula. Always good practice to go ahead and write out what your A, your B, and your C value are, just so that you have a good thing to look back to double check your work. So again, I plugged in things into the formula from the equation in their appropriate places, and now I'm going to keep simplifying. Okay, so I did a couple steps in that, and so here I simplified all of this and got 9 plus 160 and a 4 down there, and of course that became positive 3. 9 plus 60 is 169. Square root of 169 is doable without a decimal in this problem, which is 13. So now I need to cut it up into my two answers. So it's just x equals 3 plus 13 divided by 4 and 3 minus 13 divided by 4. Order of operations is greatly important here. So you must do everything on top before you do your division step. So x equals 16 over 4 and x equals negative 10 over 4. And now we need to simplify as far as we can go. And we get x equals 4 and x equals negative 5 over 2. And these are the two x-intercepts for this quadratic equation. This is where the two places that this graph will cross the x-axis. Okay, so our next problem, I already labeled my a, b, and c, but it's 5x squared plus 9x plus 4. So my a is 5, my b is 9, my c is 4, and there's my quadratic formula. So now I'm going to plug things in. Okay, so I cruised through. I plugged the places, the variables in, or the values into their proper places in the quadratic formula. Then I went ahead and simplified. Now this negative 9 stays a negative 9 because that b was positive, so that's why in the formula it's negative. So unlike the previous two problems, it stays. This 81 minus 80 over 10, okay, square root of 1, because 81 minus 80. So again, that sign didn't end up changing either because of the values there. So it simply becomes negative 9 plus or minus 1 over 10. So in the simplification steps here, negative 9 plus 1 over 10 and negative 9 minus 1 over 10 simplifies all the way down to x equals negative 4 over 5 and x equals negative 1. All right, now sometimes, remember the quadratic equation we're looking for is ax squared plus bx plus c equals 0. Here's an example of this one is not set up for quadratic formula yet because it is not set equal to 0. So we have to move things to the other side to get it equal to 0 and then simplify before we can use the quadratic formula. Okay, so before we can go anywhere, we need to move that negative n squared to the left side so that we can have it set equal to 0. Okay, so to move that negative n squared, I added n squared to the left side, simplified, combined my like terms, and I get 9n squared plus 4n minus 16. We are ready to go for the quadratic formula. Let's label our a, b, and c and start plugging things in. So there we go. We've labeled. We've started plugging in, so now we're going to start simplifying. Okay, so starting simplifying, no big deal. But square root of 592 is only done in your calculator for your guys' world. So like I said at the beginning, round to the nearest hundredth, and you get 24.33. So now I'm going to go ahead and separate it into two equations, and I'm going to get decimals for both my answers. Okay, so you see what it looks like separated. So now I'm going to keep simplifying on the next step. So once you simplify all the way down, you're going to get an answer of 1.13 and x equals negative 1.57. So again, on the graph, these are going to be in between 1 and 2. You're going to see a point on the graph. You're going to see that's where it crosses. And in between negative 1 and negative 2 is where the other side is going to cross.